From our circular motion unit, we know we can find the linear velocity of an object that is moving in a circular path. And the way that we would do that is if we knew the radius of the object, I should say the radius of the object's circular path, we can find the linear velocity at any point on the circle just by taking 2 pi times r, the radius, divided by t. And that's because 2 pi r is the circumference of the circle, and t is going to be the time period it takes to travel in the entire circular path. So if we have an object that's moving in a full circle, we know it's traveled 2 pi r, and it's taken t amount of seconds, so that just gives us meters divided by seconds, which is our linear velocity. We also know that the velocity at any point on the circle is tangent to the path of the circular motion. So for example, this object is moving in a counterclockwise path. At the very top, the velocity at that point is going to be moving directly to the left. At the very bottom, we know that the object's linear velocity would be directly to the right. In terms of our angular velocity, we know that the angular velocity is the rate of change of the angle as opposed to time. So it's not 2 pi r divided by t, but we know that the angular velocity is 2 pi, the radians divided by t, and that's in radians per second. If you take a look at our linear velocity equation, if you take a look at our angular velocity equation, you'll notice that 2 pi over t does show up in our linear velocity equation. The only thing that you'll need to do in order to find your linear velocity, if you're given an angular velocity, is just to multiply that angular velocity by the radius. That's the only change. So we know that the linear velocity can be found from any object in the circular path by multiplying the angular velocity times the radius. That is how we can relate our linear velocity to our angular velocity. So what you need to keep in mind is that while the angular velocity will remain the same for any object, no matter the radius if you have a circular path, the linear velocity is dependent on the radius. So an object that is closer to the center will have a different linear velocity than an object that is farther out. But the angular velocity for both will remain the same.